For generations, Pluto was seen as little more than an icy curiosity at the outer edge of the solar system. It was too small to command much attention, too distant to reveal its secrets, and too cold to be considered an active world. After its discovery in 1930, it was proudly introduced as the ninth planet, appearing in schoolbooks and classroom posters around the world. Then, in 2006, everything changed. A decision by the International Astronomical Union reclassified Pluto as a dwarf planet, and almost overnight it became a symbol of scientific controversy rather than exploration. Many people began thinking of Pluto as a forgotten relic, a frozen remnant left drifting beyond Neptune, isolated in the darkness. But recent observations from the James Webb Space Telescope have forced scientists to look at this distant world in an entirely new way. Unlike NASA's New Horizons spacecraft, which raced past Pluto during its historic flyby in 2015, Webb studies the dwarf planet from afar by analyzing the light it reflects and emits. Instead of producing another detailed photograph, it has revealed something even more remarkable. Webb uncovered new clues hidden within Pluto's atmosphere, surface chemistry, and temperature, suggesting that this remote world is far more dynamic than anyone expected. The evidence points toward a planet that is still evolving. Its atmospheric haze appears to cool the world rather than warm it. Its thin atmosphere is slowly escaping into space. Organic compounds continue forming on its icy surface. Some of its towering mountains may actually be ancient cryovolcanoes, and deep beneath its frozen crust could lie an enormous hidden ocean locked beneath miles of solid ice. Pluto is not a lifeless block of frozen rock. It is unimaginably cold, cloaked in darkness for much of its orbit, yet it continues to change in ways scientists are only beginning to understand. Perhaps the most unsettling discovery is what Pluto represents. If this tiny world can remain chemically active so far from the Sun, then countless other frozen bodies scattered throughout the Kuiper Belt may also be quietly evolving beyond our view. Pluto may not be an exception, it may simply be the first example of a much larger mystery waiting in the darkness. The story began nearly a century ago when a young astronomer named Clyde Tombaugh made one of the greatest discoveries in modern astronomy. Working tirelessly night after night, he carefully compared photographic plates, searching for an object that moved ever so slightly against the seemingly motionless background of stars. Without the benefit of advanced computers or modern telescopes, his patience paid off in 1930 when he identified a faint object unlike anything previously known. The discovery captured the world's imagination. Humanity believed it had found the ninth planet. For decades afterward, however, Pluto remained frustratingly mysterious. Its enormous distance prevented astronomers from seeing anything more than a tiny point of light. Even the largest telescopes could reveal almost no surface detail. Scientists knew its orbit was unusually elongated and highly tilted compared with the major planets, occasionally carrying it closer to the Sun than Neptune before sending it billions of kilometers back into the outer darkness. With so little information available, researchers filled the gaps with educated guesses. Pluto was generally pictured as an inactive ball of frozen ice, a small, ancient world that had remained unchanged for billions of years. That perception lasted until 2015. After traveling through space for nearly a decade, NASA's New Horizons spacecraft finally reached Pluto. Although the encounter lasted only a few hours as the spacecraft sped past at tremendous speed, it completely transformed humanity's understanding of this distant world. The first close-up images revealed an astonishing landscape unlike anything scientists expected. A massive heart-shaped plain stretched across the surface. Towering mountains composed primarily of water ice rose above vast frozen plains of nitrogen that appeared surprisingly smooth and youthful. Thin layers of blue atmospheric haze floated high above the surface, creating one of the most unexpected views ever captured in the outer solar system. Instead of finding a dead, frozen world, scientists discovered evidence of geology, active surface processes, seasonal cycles, and an atmosphere still interacting with the environment around it. Yet New Horizons could not remain there. Its incredible speed meant it continued onward into deep space after only a single flyby, leaving countless questions unanswered. Scientists had seen Pluto's face for the first time, but they still knew very little about how the dwarf planet actually functioned. That is where the James Webb Space Telescope entered the story. Although Webb cannot travel to Pluto, its powerful infrared instruments allow astronomers to study the dwarf planet in ways no previous observatory ever could. By analyzing infrared light with extraordinary precision, Webb can identify specific molecules, measure temperature variations, and investigate atmospheric chemistry from billions of kilometers away.